Good morning, everyone. So, today let's discuss the topic active transport. Now, already we have discussed in our last class what is passive transport, isn't it? That means the transport of substances which does not involve any amount of energy, isn't it? And that which goes in according to the concentration gradient is known as the passive transport. So, active transport is that particular transport which involves the expense of energy. That means it moves against the concentration gradient for which energy is required here. Okay. Now, for example, we can take the sodium-potassium pump or the proton pump. Here the carrier proteins become activated and picks up the solute from the membrane surface and forms a complex, okay, that is the solute carrier complex. This complex, when it enters the membrane, it breaks down and releases the solute. So in that particular mechanism, actually the active transport takes place. Now next, let's come to water potential. Water potential, it is the difference in the free energy of or chemical potential per unit molar volume of water in a system and that of pure water in the same system. That means the difference between the energy of water in solution and that of water in pure condition. Okay, that is the main thing. That difference is known as the water potential. Now the chemical or water potential of pure water at normal temperature and pressure is always 0. Okay, that is a constant term that we get. Now this is calculated by the formula. This is actually used for designating the water potential. It is called psi and it is calculated in terms of bars, pascals or atmosphere. Okay, and the formula is psi w is equal to psi s plus psi p. Now here actually psi s, it represents the effect of solute on the free energy of water. That means it is the solute potential and psi p is the pressure potential. Now another also force is there which is known as the metric potential. So now let us gradually discuss what is actually solute potential. Solute potential, it is also known as the osmotic potential. It is the decrease in the chemical potential of pure water due to the presence of solute particles. That means when particles are present in water, okay, pure form, then what happened, that it creates a difference in the potential. So that particular thing is known as the solute potential due to presence of solutes in water. It is actually calculated by the formula Sp is equal to CRT. Now C, it indicates the concentration of the solute particles in moles per liter. Okay, R is the gas constant with a value of 0.083 and T is the temperature in absolute degrees. Okay, then psi p is used to denote the pressure potential or which is known as the hydrostatic pressure. It is the pressure which develops in an osmotic system due to osmotic entry of water. That means if in a cell water enters or it comes out, a pressure is being created. That particular pressure is known as the pressure potential or the hydrostatic pressure. That means when water enters into the cell, okay, that means it creates a pressure. Now suppose this is the cell, here water is entering. So what happened? This cell will become turgid, it will swell and then it will create a pressure. Okay, that is known as the turgor pressure. That means this is due to the osmotic entry of water into the cell. So it will gradually press the walls of the cell. Now this positive hydrostatic pressure or the turgor pressure develops in a confined part of the osmotic system due to the entry of water into the cell. Okay, and this actually is very much essential for the movement of the sap over the long distance in plant. That means we have already discussed that xylem and phloem, they help in the transport of the substances, isn't it, sap. So that particular substances transportation is helped by or assisted by this pressure potential part. Okay. Now whenever what happens, the turgor pressure pushes the walls of the cell. Now if the force is maximum, then what happens, these cells will get distorted, but it is not so because it is an elastic substance. Okay, it has its own specificity for which it what happens, provides an equal amount of force. That means the wall pressure is being created which is equal to the turgor pressure. Okay, so how much amount of turgor pressure is created? Equal amount of wall pressure is created in response to that. This is the balance for which the shape and size of the cell is maintained. Therefore, the turgor pressure Tp is always equal to the Wp wall pressure. Okay. Now, next is the metric potential. It is actually the decrease in chemical potential of water because of the immobilization of water molecules due to absorption over and inside colloidal particles. That means here what happens, sometimes some substances are either they are move inside or outside, and due to that what happened, there is a decrease in the chemical potential, that is osmotic potential, for which what happened, a particular decrease is observed, and that particular thing is known as the matrix potential. Okay, metric potential, and the value of metric potential is always negative. Got it? But sometimes it can be positive, but which is positive, not less than 0, so it is negligible, so it is always negative. Now, the next important thing for transport is the diffusion pressure deficit, that is DPD. Now, diffusion pressure deficit means it is a reduction in the diffusion pressure of water in a solution over its pure state. Okay. Now, let us consider these cells. Okay, we are considering here 3 cells. Now, we know that roots absorb water. Okay, a very simple example. Now, here what happened, the water enters into the first cell. So, when water enters here, then what happened, it will create a diffusion pressure. That means due to diffusion, water is getting entered into the cell, it is becoming turgid, and it will create a pressure, that is the diffusion pressure. Now, the second cell, what happens here, the cell is dry. So, the water will move from the first cell to the second cell. Got it? That means water will move from here to here. So, when the water is moving from here to here, that means what happened? Here the diffusion pressure will increase. Simultaneously, what happened? The first cell will, here the diffusion pressure will get reduced. That means here DPD is being created, diffusion pressure deficit. Got it? Again, the second cell DPD is diffusion pressure has been created. This will help the water to move to the next cell, third cell, and so the second cell will now have a DPD, diffusion pressure deficit. So this way, when here DPD is increased, that means what happened? It will have a suction force for which the water is being transported to from the surrounding into the cell. Okay, that's why DPD is also known as the suction pressure. Got it? So this is a very important mechanism for the water absorption, that means transport of water, which takes place from cell to cell movement. So always remember, when DPD increases, water absorption takes place, okay, or suction takes place, and when DPD decreases, water absorption doesn't take place. That's the reverse thing happens, and this is calculated by the formula DPD is equal to OP minus TP. OP is the osmotic potential minus the turgor pressure, okay, or osmotic pressure minus turgor pressure. And here we know that turgor pressure is equal to the wall pressure, that's why we can also say OP minus WP also, okay. So these are all important things regarding the water potential parts. Go through it, go through the books also, okay. This is an important thing. So if you have any problem, if you have any difficulty in understanding it, then please let me know.